Howdy, everybody! Merry Christmas! It's coming. The holidays are here. I hope everybody's doing good. We're gonna have some fun today. How's everybody? Let me just check how the stream is looking. Let me just grab some coffee, guys. So, hope everybody had a good weekend, though. Had a great weekend. Had a lot of good people help me out over this weekend. Yeah, I mean, it's just, man. It's like the blessings are just coming and coming, guys, and I hope you guys are getting, all your hopes and dreams are coming true as well, and that you're seeing, the good that's in life right now. No matter how bad I guess the situation can get, there's always some good that comes out of everything. All right, guys. And I pray for every single one of you guys out there. Like I said, I've had some really, really awesome people over the last couple days. Yeah, just it's outstanding the amount of love that I've been witnessing lately. From people that I've known for a long time, showing me a lot of love, to even new people that I've just met, showing me a lot of love, and I'm in awe, complete awe with just how everybody's just so awesome. And I love every single one of you guys. Again, I can't say it enough. Thank you, thank you, thank you, thank you, thank you, thank you, and thank you again to everybody out there. You guys are all amazing. You guys are some outstanding people. Yeah, and yeah, I can't say it enough. You'll probably won't hear me say it enough because how great everybody has been. And it's a lot. It's just, I mean, even again, I've been seeing. Yeah. I'm again. I'm gonna be stumbling. I'm gonna be almost in tears if I continue on. It's just. I mean, I gotta look. Even again, I've been. Alright. I'm looking good. Everything looks good. The stream looks good. I hope you guys enjoy. Hope you guys enjoy some of the little holiday decals I added to everything. I thought this was the right tone to set for where we are in the year. This has been a tough year on everybody. This has been an extreme year for everybody. And we're coming on the close of it. And like I said, I just hope and pray that everybody out there is safe, is feeling some love from somewhere, from somehow, from somebody, that somebody around you is loving you. So if you're watching this, I love you. All right. So if you don't think there's anybody out there that loves you, I love you. All right. So there you go. Let's get down to brass tacks here. So we don't get too far off. Today, guys, like I said, I know I didn't stream yesterday. Just I was working on a lot of stuff. I worked on some of the stream, how it looks and stuff like that. Worked on some of the underlying stuff, trying to get my Discord together. That's almost put together. Pretty soon we'll have a Discord. We'll have a Discord channel, guys. That we can continue some chats. That we can. That I hope to supply you guys with some packet tracer stuff on there, so you guys can play along with packet tracer. Hopefully soon. For you more advanced folks that might be watching this, pretty soon I already have GitHub, but pretty soon I'll have it more integrated to what we're doing here, and I'll be able to share what my network topologies that I've been building in CML over on GitHub. If you know, again, if you're one of the advanced crowd that are watching this, I believe it's all an XML file. It'll be an XML format that I can boot up, that I can upload to Git, and you guys can get obviously off GitHub from there, off of my little GitHub repository. So soon that'll be coming. Again, you'll have to have CML. But if you can read XML format, you'll be able to see, line by line, all the configurations that I've been inputting. That whatever lab it is that I did, you'll be able to see the configuration. So that'll be coming. So we'll have some Discord integration. We'll have some GitHub integration here very shortly. I want to give a big shout out to, again, my big sis and her fiance. You guys are awesome. I love you guys. You guys are the continuing to be the biggest supporters of this this undertaking that I'm trying to do right now. And I love you both. You guys are phenomenal people. You guys are great people. Thank you so much again. I also got to give a big shout out to my boy Prosper. I met him just last night. I'll tell you what. Again, new person I met in my life, and showed me some love, and brought his community around me, and they all just came around me and just brought me right in, showed me some love. Same thing with the Gooses, the Bruce's Gooses. They're an awesome folks. Every single one of the Gooses. I've been on their Discord for the last couple weeks now, and I tell you, they are some phenomenal people on there. I love every single one of them. All they want to do is prop people up. They don't deal with no booty crap from people that want to tear people down. They don't deal with that. They'll rip you up. They'll eat you. They'll attack. All the Gooses will come and eat you. But I tell you, if you come in there with the right attitude and the right state of mind, and you just wanna show love and be loved, man, those Gooses they'll flap you in their flappy arms. They'll bring you in. They'll bring you into the love pond that they all sit in. So big shout out to the Bruce's Gooses and Bruce Green himself. So there's some shout outs. From there, guys, let's get talking. Let's get talking on what up? Lalant, my boy followed me too. Man, awesome, man. You guys are awesome. I swear, every single one of you guys. So let me give another shout out to Leylandia, if I'm pronouncing the name right. I've been watching his channel too. He's another awesome fella. Awesome people, man. I'm telling you, again, there's some more love right there, guys. Again, shout out to you too, my brother. Thank you so much. Again, I appreciate the love. All right, let's get down to Brass City Tax here, and let's do it. So, part four today. We're gonna be starting off on chapter. Kill the music now. Let's go over to. All right. So we're I don't know if any of my things are working. We'll find out if any of my things are working. Doesn't look like they're working. I still gotta work on some of what I've been trying to build the stream off of to look like. Again, these shout out to the people at Streamlabs. they offer, some awesome stuff. So, all right. So let's start off where we're going to be getting into. All right. So again, part 4, IPv4 addressing. All right. So what happens is at this point in the book shifts from layer 2, all right, MAC addresses, frames, all right, and we're going to get into layer 3 now. Okay, we're going to be getting into the network level, IPv4 addressing, subnetting, and that's going to take us. The step we're taking now is a necessary step because how hard this is to kind of wrap it for a lot of us. This is going to be a hard one for us to wrap our heads around. So that's why this is going to be a very important chapter, and this is something that again I really need to focus on. I need you guys to help me along with how we're going to be learning this. So just to give you a broad perspective, so IPv4 subnetting, analyzing classful. So classful IPv4 networks, we're going to talk about that. We're going to be analyzing subnet mask, okay, and why that's important. All right, and then analyzing exit mask. So what we're going to be these next 4 chapters, they're broken down in a sequence, and the sequence is going to be important for us to follow. So our understanding of how to, first off, look at an IPv4 address and know what it means. Secondly, how to create and design our topology that not only will work, but is actually thoughtful and ideal for your design. All right, and we're gonna get into some of the ideas and some of the thoughts that go behind why a network topology addressing is the way it is. All right, or why is it in your, why are you making the opinion that it could be better in a different way? So that's what else we need to get into. And then again, on the actual exam, when it comes to exam time, the exam itself is going to be full of subnetting questions, and we have to have the ability to be able to crunch out these mathematical answers within a certain time frame. We got to be blasting through here. And what we'll do is I'll get I'll pull up the Pearson subnetting stuff too, and we'll go through a lot of those tests. We'll keep on going through them and going through them. There's one out there that has like 800 questions, and I think that'd be a great thing for us to really hammer our heads with. That way, again, when it comes to the time when we're gonna take that exam, subnetting will be second nature to us. We'll be able to blast through subnetting like a champ. All right. So with that being said, let's start off. And again, this is a quick recap of what we're going to be getting into. Now let's dive into. Let's do a small recap of the previous topics that we've covered before. That way we can keep the juices of those ideas in our mind still. We won't take the 75 question test like we took last week. We'll cut that in a quarter, about 25 or so questions. That way, again, we can keep that. We can keep those ideas still fresh within our minds as we continue to move on to different subjects. All right. Again, guys, if at any moment, hit me up in chat to discuss what we're talking about. All I ask though, and I'm going to ask this going forward, is do your best to pertain any questions to the chapter or subject that we're actually talking on about during the stream. When it comes to lab time, though, that would be the time for packet tracer questions, mainly around the installation of packet tracer questions. I will do my best. I again, if you're doing it, if you're downloading it to Windows or Mac, those are always easy. If you trying to get it onto Linux, that's a complicated process that I probably won't even get into. But again, if you want to get packet tracer downloaded, I suggest on Windows or Mac. Those are the easiest two operating systems to get packet tracer downloaded to. And packet tracer is a free software. It's an excellent software. And if you're interested or want or maybe just curious about what we're talking about here, what we're doing, packet tracer would be the greatest place in the world for you guys to start. All right. So with that all being said, let me just take one more sip of my coffee. It's been a long day. I was up pretty late last night, and yeah, I think I might have got an hour of sleep, and then I've been rocking and rolling all day because I had my first day orientation over at because I got two jobs coming down the pipeline. Well, one job I got. Finally got, like I said, today was first day orientation for a shift supervisor at CVS. Again, these are all miracles, guys, that have just been coming around. And then I have another potential. I got everything already in the books and everything for the post office. So I'm trying to do my best to get inside the post office, guys. I would love to get back into a federal position again. That's where I want to be. So, today was orientation, and then after that, I had to I got into doing all the security stuff for the post office and stuff. So, been a busy day. Yeah. So, if I seem a little offish and not very, I guess, straightforward like a bullet like I usually am, that's just because it's just been a long day. That's it. But been a great day. Great day. Don't let me fool you that I'm not doing all right. I'm doing great. Everything's awesome, guys. All right. Yeah. Let's get on here. All right. Get on to the business. The bee's knees. All right. A little bit of clock. All right. There. Handy schmandy. Wireless mousey mouse. No, I didn't add a viewer count. It's all good. I'll add it later. All right. Yeah. Let's dive into it, guys. All right. Let's hit up the practice exam real quick. This over here though, so I can monitor chat. All right. Like I said, we won't go through the whole shebang. We'll just do a quarter. We'll do a quarter of the test questions that we've done. And let's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've gone up to 10. So let's go from there and see how many questions we got. All right, we got 20 more questions. Cool. All right, which of the following terms represent a layer 3 PDU in the OSI model, which includes network layer header and encapsulated data. All right, so network layer 3 PDU, remember, so that'd be packet, guys. So IP packet. All right. All right, IP functions. IP functions at what layer of the OSI model? All right. So again, we were just talking about this. So we're on the network. So IP functions at network, which is the third level in the TCP IP model or OSI model. They keep talking about the OSI model, but it's TCP model or OSI model, same thing. So the network in the figure uses Cat5 cabling, IJ45. Which of the following statements is true about the wires inside the cabling? So remember, routers, PCs, access points all have that same type of logic, where they and then switches, bridges, and hubs have their own same logic. Okay, all right. So the cabling from nope. How many we have to choose? 3. That one's this one's right. Yeah, that one's right. Nope, that one's wrong. That one's right. And this one's right. So remember, from switch to router or switch to PC, that's straight through cabling, guys. Okay. Switch to switch, switch to bridge, switch to hub, that's crossover cabling. Pin 1 connects to pins 3, pin 2 connects to pin 6. Okay. All right. Refer to the diagram. The new connection that goes between campus 1 and campus 2 router is required for 500 megabytes per second, and the routers are 3,000 meters apart. So we want to think big. We want to think Zulu. All right. The diagram refers to what cable? So remember, bigger core. That's multi-mode. Okay. It's called multi-mode. Which protocol finds an unknown layer 2 address, an unknown layer 2 address from a known IP address? So which protocol is trying to find the MAC address to a known IP address? Okay, remember, that's ARP, Address Resolution Protocol. All right. Which of the following data link layers protocols are used to encapsulate data in a lease line? So we have HDLC and we have PPP. Okay. All right. How does the receiver of a HDL frame know what has been encapsulated within the frame? And that's the type. All right, in the header. When the Cisco iOS CLI is initially accessed via the console as Telnet SSH with no extra privileges, which mode is the user placed in? So remember, when you just log right in, what mode do you fall into? That's user mode. Okay. Now, if you can set the privilege to a higher level, and that the highest level will get you from from logging in straight to enable mode. Okay. If you set that to 15. All right. After powering on the frame, just grab some more coffee, guys. I really need coffee tonight. I apologize. I keep going backward. I really need it tonight. After power on, a frame arrives at the switch. The switch has not yet learned the MAC address of the frame. Which of the following actions must take place? All right. In this case. So the switch adds the source MAC address to its table, okay? Not the destination in source, all right? It adds the source, all right? That's how it builds that MAC address table, okay? Because it gets from the source, it says, okay, out of this interface, port interface, this MAC address lives out of this port interface, okay? But it forwards it based on the destination, okay? All right. All host switch ports reside in VLAN 1 with no port security, no MAC address tables entries defined. Host B remains powered off. All other hosts can ping each other successfully. Later B powers up, and the user pings 10.1.1.4 command to generate host B's first network traffic. Which answers describe the frame forwarding in this scenario? So we're going to select 2. So remember, Mr. B over here, Mr. BBBs. Where did my epic pen go? What's going down there, buddy? Did it break again? It did break. Man, I don't know why. Ever since this update they did, Epic Pen broke. Epic Pen broke again. There we go. Let's see if it turn on now. Come on, Epic Pen. Don't fail me now. There we go. So host B, okay, all right. When it sends out, when it just turns on, okay, what's gonna happen, guys, is this switch is gonna forward it, okay, out all its interfaces. So it's gonna forward it out of 501 gigabit 0-1. All right. When this switch gets it, it's gonna forward it out of 503, 504 gigabit 1. All right. When this switch gets it, it's gonna flood it out of 505 and 506. Okay. So everybody la-di-da-di is going to get a copy of this frame. So the frame will be forwarded to host D. Yes, it will. The frame will be forwarded to switch 2. No, it's going to go to switch 3 too. The frame will be forwarded. Yep. Yep. All right. Continue on. Which answer encrypts the password that required a user after he types the enable is that command. So encrypted password after to get into enable mode. So we're looking at enable secret password. The secret shows some configuration command that sits in a text file after adding the configuration to the switch. The user attempts to connect to the user Fred and password hope. Which of the following best describes the accuracy of the configuration for allowing a user attached to subnet 10.1.1.0/24 to use SSH on the switch? Let's take a look at the exhibit. Yep. Good. Looks good. Looks good. Doesn't look good. So right here, guys, it's only pretty much stating that it's only looking for a password, a single password. It's not looking for a user password combination. Okay, so by the administrator adding the username Fred with password hope, he failed to use the correct configuration setting on the line VTY line so that he can use that password username combination. Okay. Yep. So it's A. Refer to the exhibit based on the information shown in the exhibit. What can be said about the configuration of gigabit 0-4 interface? So gigabit 0-4 connected half and 100. All right, but it's a 1000. It has the ability to be set at 1000. So the speed and duplex have been set. All right. So the duplex has been set to half and the speed's been set to 100. Refer to the diagram. Both switches are Cisco switches. What would the state, speed, and duplex of the links refer to the switches? To SW1. Auto negotiate fails. All right, but that's due because switch 2, the administrator set the interface on gigabit 0-0 to speed 1000 and duplex full. So because the engineer manually set that, all right, auto negotiation is failing on switches 2 gigabit 0-1. So it's going to be up and full, all right, because of those settings right there. All right. What is true about the command switch put non-negotiate? So that's pretty much going to prevent a trunk from happening. All right. So non-negotiate, we're pretty much telling the interface that we, out of no circumstances at all, do we want a trunk to be formed on this switch. So if connected to a switch that uses dynamic desirable, the neighboring switch will not trunk. Very true. Okay. All right. Based on the figure, what Cisco iOS command would you use on a switch to correctly configure switchport 0 fast Ethernet 0-1 to be an access port in VLAN 30. So we're just going to give it the simple switchport access VLAN 30 command. All right. Very simple. All right. Which of the following are functions provided by span and tree protocol? So we got to choose 3. So what does span and tree protocol do? It prevents broadcast storm, prevents frames from going through that topology for an endless amount of time. It prevents MAC table instability, because remember that those switches are flooding that frame, but they're flooding it in all directions. So it's flooding it out of all those ports that have a connection to it. So what's going to happen is that frame's going to appear to be coming through a different interface port with that source MAC address, and that switch is going to think that now that resides out of this interface when it possibly doesn't. All right. So yep. Nothing layer 3. No broadcast and MAC instability. Okay. All right. An SDP topology. Ooh, what's up? You are frozen for me. Hold on. Hey, baby. Am I frozen? Let me check it out on the. I just hold on one second. I think I just heard somebody knocking. Hold on one second, guys. You guys hear somebody knocking? You just keep your ears out for it. Somebody was there, but it wasn't for us. Sorry about that, everybody. Sorry about that. Hey! All right. Thank you, baby. Yeah, sorry about that, everybody. I had a knock at the door. We don't usually get visitors, so. All right. An STP topology with 3 switches has one link between each pair of switches, which best describes the primary decision point as to what non-root switch has a designated port of links between switches and which doesn't. So the switch with the lowest root cost will be designated, and all the switches will be blocking. So the switch, yeah. So the switch with the lowest root cost. Remember, the lowest root cost will all of its interface ports will be in the designating state. Okay. No, not that one. This one. All right. Come on, mouse. Come back. All right. The exhibit list out. The exhibit output from a switch. Which 2 statements are true? So let's take a look. So, VLAN 30. Yep. Oh yeah, I can I forgot to add the my wife's watching me on YouTube right now. Yeah, I forgot to add the counter, to the new to the new to the new setup tonight. That's why I'm not seeing the That's why you're not seeing the thingy. Yeah. She's laughing at me. All right. So I gotta read that question again. The exhibit lists and output. Which of the two statements are true? There are 30 switch. No, there's no 30 VLANs. The switch is the root for all VLANs on the switch. Probably not. All designated ports are in the forwarding state. The bridge priority is lowest value in the span tree protocol. Let me just take a look. So yes, and yes. Okay. So it's the last two. All designated ports, and the bridge has the lowest. So we have no idea how many VLANs. It's not telling us that. And we have no idea if it's the root switch for every VLAN. It could, with Spanning Tree Plus and RS with Rapid Spanning Tree Plus, got to remember those are taking care of multiple VLANs. That's why they're the plus. Okay, multiple VLANs. All right. That switch may not be the root switch for multiple VLANs. It could be, but it could not be. So, when configuring interfaces to be part of the same Ethernet channel, which of the following should be configured identically? You got to choose all allowed VLANs on a trunk. Speed, yep, speed, duplex, access, and trunk. So they all have to be trunk ports. They all have to be access ports. The speed has to match and the duplex has to match. So let's say that again. So on all to configure a Ethernet channel correctly, all the traits from one interface to the next, I'm going to say traits, they all have to match identically for that Ethernet channel to be created. Because you got to understand, you're creating, even though physically it's multiple ports, logically you're creating one logical port. So you have to ensure that all the traits are exactly the same. So logically that can make one actual logical port. All right, I think we did. Yeah, I think we got 100%. We're good. Again, I just wanted to touch up on what we've covered so far, just to maintain that this stuff stays in our memory. We went 1,000. All right, very good. We can close that out. All right. Now let's jump into covering chapter 11 now. Let me grab some coffee. Coffee. All right. That's all I got left. All right, so let's dive into it. Chapter 11, perspective on IPv4 subnetting. Okay, so what is this going to cover? Most entry-level network engineer jobs require you to operate and troubleshoot a network using pre-existing IP addresses and subnet plans. The CCNA exam assesses your readiness. Love you too, baby. Go back to work. Love you, baby. I love my wife. She's awesome. That's another one, guys. Another one that just continues to show me outstanding love during this time right now is my wife. She's my rock. She's everything. She's been there, and we've been through some really tough times together, and she continues to stand by me. So I love you, baby. Have fun at work. So, all right. Pre-existing address and subnetting information to perform typical operational tasks such as monitoring the network, reacting to possible problems, configuring addresses for new parts of the network, and troubleshooting. So, this is why the CCNA is going to be very hot up on us on subnetting, and in our understanding of subnetting and subnet mask and whatnot, because it is fundamentally one of the most important things to understand addressing. Okay, because if we don't understand addressing, how are we going to be able to create topologies? How are we going to be able to troubleshoot topologies if we don't understand how we actually address our topologies? We can't just blatantly just give out random sets of numbers. It goes to the logic of just like the post office. And I knew I grabbed my markers. There they are. Get a new black marker. Today we'll start off with a new black marker. So let's get started. All right, so it just gets back. So here's Boston. All right, LA. All right, and good old we'll say Colorado. Okay, good old Colorado. All right, Colorado. All right. Obviously they're on either side. All right, you have the East Coast, West. All right, and then you have the pretty much like the middle of the country. All right, the Midwest. This is the Midwest. Just call it Midwest. All right. All right. You're not gonna have the same zip code. All right, in Boston, and have that same zip code in LA. All right, you're not gonna have it. It just won't be the same. All right, so we'll take for instance, 0. What's a common 0, 1, 8, 7, 3? I think is Boston, and I think LA. What's LA? And I used to know these. Whatever. I'm shooting from the hip. It's like 7, 3, 5, 6, 8. We'll say, and maybe Colorado is maybe 8, 7, 6, 5, 2. Again, I'm shooting from the hip. I'm probably way off, way wrong, but you're not gonna have zip codes in the same range that you would have, say, in LA or Colorado or Boston. They're all going to be different. They have to be different for purposes of routing that mail to one another. All right. Maybe this might have been a bad example, but it's all. If you can think of how the mailing system works, it's similar to how IPv4 addressing works. All right. Tom down the street can't have the same address as Sally. All right, in the next town. All right. They won't have that same address. All right. The addressing will be different from one another, and that's what we have to learn. That's what we're gonna learn as we continue on here. All right. So let's keep it moving. All right. There you go. All right. Let's do the Do I Know This Already quiz real quick. Host A is a PC connected to switch SW1 and assigned to VLAN 1. Which of the following are typical which of the following typically assign an IP address in the same subnet as host A? Host A is a PC connected to switch 1 and assigned to VLAN 1. Which of the following typical assign an IP address in the same subnet as host A? So it's just asking what else is going to have that same subnet. So the wide area network interface is different. Most likely it's different. The local router, the local area network interface, that's going to have the same. All other hosts connected to the same switch. No, because you can have different VLANs, and different VLANs can have different broadcast domains. All other hosts attached to the same switch also in VLAN 1, so it's D. So let's go with D and B, or B and D. I'm going to say 1. I'm going to say B and D. All right. All right. What does the formula for the number of hosts per subnet, 2 to the h minus 2, require the subtraction of 2 hosts? So this right here is a very important, and we're going to learn about this. This is a very important equation, guys, because what that is doing for us, it's eliminating the broadcast domain, and it's eliminating the subnet address ID. So like the identifying address network. Okay, so it's removing the network ID and the broadcast address. All right. To reserve 2 addresses for redundant, nope. To reserve 2 addresses, nope. To reserve two addresses for the subnet ID, yep. So the subnet ID and the default gateway, no, it's not that one. To reserve 2 addresses for the subnet, the subnet broadcast address and the subnet ID. All right, so it's D. So 2, we're gonna go with D. All right, let's go with D on that one. A Class B network needs to be subnetted that such it supports 100 subnets and 100 hosts. Which of the following answers list a workable combination for the network and of number of networks and subnets and host bits? So host B needs to be subnetted such that it supports 100 subnets and 100 hosts per subnet. Which of the following answers would list a workable combination for that network, subnet, and host bits? So choose 2 answers. Let's take a look at our options here. So we have 16 and 8. Let's go with B and C. So we'll have 16 networks, all right, 8 subnets, and 8, and then, all right, let's go with B and C. Shooting from the hip on this one. All right, I got to get better at my subnetting, but I'm pretty sure it's B and C. All right. Again, we shouldn't be guessing at these. I know I shouldn't be guessing at these. All right. That's why we really gotta focus on it. Which of the following are private IP networks? So this goes into the classful, the IPv4 classful IPv4 networks. Okay. So what do we got? 172.31.0. That looks good. 192.168.245. Ooh, that looks good too. 192.1. Nope. That's no good. That's no good. And that's no good. So it's A and C. It should be A and C. I believe it's A and C. So 4, A, and C. All right. Which of the following are public IP networks? So we got to choose 3. So this one should be easy for us to blast out. So 5. We're going to say A. I'm already seeing a couple. A. D is 1. And E is 1. All right. Yep. So A, D, and E should be those. Before Class B network Before Class B network 172.116 is subnetted by the engineer, what part of the structure of the IP address what part of the IP address in the network already exists with the specific size? Class B network is subnetting by the engineer. Which part structure is already network specific size? Choose two. Class B network is subnetted by an engineer. What parts of the structure of the IP address in the network already exist with a specific size? We're gonna go with network. So let's go. How many are we gonna choose? 2. Let's go 6. Let's choose B. A. I mean A. And D. All right, A and D. Let's go with those two. All right, a network engineer spends time thinking about the entire Class B network. Thinking about the entire Class B network 172.1.16.00 and how to subnet that network. He then chooses how to subnet this Class B network and create an addressing and subnet plan on paper showing his choices. If you compare his notes about the network before subnetting the network to his thoughts about after this network, after manually subnetting the network, which of the following occurred to the parts of the structure of the address in this network? Boy, this is a wordy question. Holy guacamole. I'm just drinking some water now, guys. All right. Holy guacamole. A network engineer spends time thinking about an entire Class B network. Okay. He chooses how to subnet the Class B network, creates an address and subnet plan on paper. Showing his results. If you can compare his notes about the network before subnetting the network and his thoughts about the network after mentally subnetting the network, which of the following is true? Which of the following is true? The subnet part got smaller. The host part got smaller. The network part got smaller. The host part was removed. The network part was removed. So it's not the last two. The subnet part got smaller. The host part got smaller. The network part got smaller. So it would be the network part got smaller. Yeah, because then, no, the host part got smaller. I apologize for that. The network is going to stay exactly the same. The network is not going to change. All right. So the host part is going to be the only thing that changes, I believe. Yeah, it is the only thing that's going to get changed, and it's going to get smaller and smaller and smaller. But it could be A though. I'm stuck between A and B right now. But I'm going to go with B, my first answer. Usually, first answer is always right, and then I second guess myself. Screw the pooch. All right. So what do we got? We got B and D. Correcto. All right. We got D, good. B and C, good. A, C, A, D, E. We're doing pretty good, guys. Ooh, we got one wrong. Got one wrong already. So this is a C. So let's take a look at what that is. And then B. So we got that right. All right. So the host part got smaller. Now let's take a look at what I got wrong because I chose D. So the host. So is network. What did it say? For 6. Network and host. So before a Class B network, once I do is subnetting by the network engineer. What part of the structure is the network What of the network already exists specific to and what specific size? All right, that's cool. Man, I'm like tripping over my own words tonight. I don't know what's wrong with me. All right. All right. Yep. So we can kind of skip that part. All right. Subnetting defined through a simple example. An IP network, in other words, a class A, B, or C network, is a simple set of continuous number IP address that follows some preset rules. The class A, B, and C rules define for a given network. So the class B, A, B, and C rules define that for a given network. All addresses in the network have the same value in some of the octets of the addresses. For example, Class B network 172.16.00 consists of all IP addresses within addresses that begin with the 172.116 all the way up to 172.116.255.255. All right, Class A network 10.0 includes all addresses that begin with 10. So, what this is starting off with. Let's start right now. We might as well just start 172.16. All right, .0. Then we got 10.0.0.0.0. Okay, so this is Class B. So we're going to write class. This is a Class B address. This is a Class A address. Now this is classful IP addressing. Okay, classful IP addressing. Okay. All right. What it's pretty much stating is 172.16. This is the network. All right. That's the network. All right. .00. These are the hosts. All right. So network bits, host bits. Okay. All right. Class A. Network. All right. 0.0.0. Host. All right. So if you're kind of guessing what I'm going to say next is obviously with the Class A classful A network, you're going to be able to get more hosts out of that network. All right. You're gonna be able to get more addresses out of a Class A network. All right. Class B, you're gonna be losing some of those networks. You're gonna be having a smaller network topology. Okay. Class B is a larger network topology. Class A is a larger network topology. Class B is a smaller network topology. Then we get into Class C. All right, and that's the 192.168.0.0. All right. And then to get back to our coloring here, 192.168 network. All right. And then host. All right. So we have A, B, C right here. All right. And then again, as we step down, Class C has even less address ranges than per se Class B there. Okay. All right. Move on. An IP subnet is simply a subnet of Class A, B, C networks. In fact, the world subnet is a shortened version of the phrase subdivide network. For example, one subnet of Class B network 172.16.0.0 could be the set of IP addresses that begin with 172.16.1. All right, so we can add a 1 here. All right, if we did this, we added a 1 here. Okay, what's going to happen now is this octet now. This octet is going to find itself within the network now, and now that's part of the network. All right, and then this guy right here, he's still part of the host. All right, so he's still a host member. All right, so in that example right there, we just added a new network to that topology, well, to that addressing range. There you go. All right, continue on. Did that pop up on? No. All right. So subnet plan. So here's a quick. Let's just go over this real quick too, because this is nice. All right. So this right here is just breaking it into examples. So 192.168. All right. So there's our network. All right. 192.1. Man, I am fumbles today. 172.16. Okay. 172.16. 172.16. All right. All right. But we're adding another octet now. So the 1, the 4, the 2, the 3. All right. And I didn't see this one. The 192.16.5. Those are all their own networks now. Okay. All right. Yep. So the subnet plan document. Just keep scrolling down. These are a little bit wordy. We don't really need to get all this right now. All right. Most IT. Yep. We have to have an understanding. And here's just a quick synopsis. Analyzing needs. Subnets host. One-size subnets. Design subnets. Plan implementation. All right. This is why I like DHCP servers. DHCP servers are great. Once we learn a little bit more, and you guys you guys were here probably in some of the labs that we've done together. DHCP pretty much takes care of all of the addressing and stuff like that dynamically. Okay. All right. All right. Analyzing subnetting and address needs. This section discusses the meaning for 4 basic questions that you need to analyze that can be used to analyze an address and a subnetting need for any new changes or enterprise networks. All right. Which host should be grouped together in a subnet? So we want to understand. Are we all in Boston? All right. If we're all in Boston, then we all should be using that same zip code. All right. All right. So which host should be grouped into the same subnet? So we got a couple houses. All right. All right. They're all in one city. All right. So maybe that whole entire area should have a single zip code. Okay. All right. Again, you're the network engineer. You're going to do what's best for your network. I'm just trying to stay a very high level of what we're talking about right now. Okay. So again, we got our zip code because we have multiple houses within a certain demographic area. All right. And because they all reside in that certain demographic area, we should make our postal service a little bit easier to understand for the postman and keep them all within that same zip code. Okay. All right. 2. How many subnets does the internet network require? All right. How many subnets does the internet network require? All right. You gotta ask yourself, is there what are the many, why do I need multiple subnets? Why do I need multiple broadcast domains within my network? Am I trying to do something with the traffic? Maybe I don't want certain traffic going to a certain address range. Maybe I have 2 different departments and I don't want those same departments to be on that same local area network. I want to give those departments their own separation. Okay, so I can better troubleshoot if a problem occurs. Okay, all right. How many host IP addresses does each subnet require? So Again, we want to do some kind of like planning, some kind of forethought. You don't want to give, say, a small office, a subnet range, uh, of like, we'll say a thousand IP addresses, even maybe more, up towards 10 to 16,000 IP addresses. Do I want to give that small office that only has 3 employees in it, a couple of IP phones, and maybe a printer and a couple PCs? Do I want to give them 16,000 addresses in that office? No, I don't want to, because it'd be a waste. We're wasting those address ranges at that point. So that's why we want to ask ourselves, what are we trying to do? What is the purpose of us doing this subnetting? Okay, all right. Will we use a single subnet for? Will we use a single subnet size for simplicity or not? Again, that goes back to, do you just want a whole bulk range of addresses? That's fine if that supports what you're doing. But if you need a more complex topology, again, to separate things, to make things, to make a more secure topology, then maybe yes, maybe breaking things up to smaller bytes, smaller sections, would be towards your advantage as the network engineer. All right, rules about which host are rules about which hosts are in which subnet. Okay, every device that connects to the IP network needs to have an IP address. These devices include computers, used by end users, servers, mobiles, laptops, IP phones, tablets, and network devices like routers, switches, and firewalls. In a short, any devices that use IP to send and receive packets. Okay, so any device that you can ping, that you can use the ping command, that can send packets, that you can put an IPv4 address to. What is the size and the simplicity that I should be making? That's it. All right. Rules about rules about which hosts are in which subnet. We just read that. All right. Key topic. Addresses in the same subnet are not separated by a router. All right. So what is it saying? An address in the same subnet is not separated by a router. What that's stating is one subnet over here, both A and B, they have the same subnet. They're working off the same subnet. Okay, even though, per se, we have a switch missing, but Mr. B over here, he might, because of this router interface, you can do some stuff where, yes, you can have the same similar type setup as that topology has, but it's not going to relate to that same addressing. Okay. Again, this is representing that squiggly line, that electric bolt right there. That represents a serial link, a wide area network link, and a link that spans multiple feet, multiple distance. Okay, all right. A PC and the idea that host on the same link must be in the same subnet is much like the postal code concept. So same thing. All mail addresses in the same town use the same postal code or zip code in the United States. Okay, so postal code or zip. All right. Addresses in another town, whether relatively nearby or on the other side of the country, have a different postal code. The postal code gives the service a better ability to automatically sort mail to delivery. So hold on, I need some air. Getting hot here for now. What's going on? I don't know what's going on there, Betsy. Alright. Alright, let's continue on here. Alright. Note that the point-to-point WAN link in the figure also needs a subnet, so it's saying that this link right here also, we also are required to give our serial link, our WAN link, a subnet, okay? All right, that because remember, we have interfaces right here, and we have another interface on this router right here, so each interface needs an address, all right? Each network interface card needs an IPv address assigned to it, okay? That way it can communicate, all right, and receive, all right, packets, okay? All right. Yeah. Finally, because of the router's main job to forward packets from one subnet to another, routers typically connect to multiple subnets. For example, in this case, router 1 connects to the local area NAN subnet on the left, and on the WAN subnet to the right, R1 will be configured with two different IP addresses per interface. The addresses will be in different subnets between the interface connected to the routers. Oof, man, I am Joey Fumble McDumbles right now. I'm fumbling over words, stumbling. Hold on. I apologize, guys. I'm usually not this. Like I said, I only got an hour of sleep last night. Wasn't the best choices. All right. Determine the number of subnets. To determine the number of subnets required, the engineer must think about the internetwork as documented and count the locations that need to be subnetted. To do so, the engineer requires access to the network diagram, VLAN configuration details, and details about the WAN links for the types of links discussed in the book. So, yeah, cool. So this is just breaking out another network topology. All right. So we're gonna have different IP addresses for each link going out to each different router. All right. Same thing that's going on with the routers themselves. All right. And same thing that's going from the switch to the router. All right. All right. The number of subnets required cannot be fully predicted with only this figure. Certainly, the 3 subnets will be added for the VLAN link, 1 per link. However, each local area network switch can be configured by a single VLAN or multiple VLANs. You can be certain that you need to at least at least 1 subnet for the local area LAN at each site. All right. So by it representing these cool little animations here, all right, what it's pretty much states is we're getting each one of these switches has multiple VLANs. Okay. All right. And then here we even have some VLANs, subnets happening right here. Yeah. Man, only guacamole, guys. I think I need more coffee or something already. All right. All right. 4-site internet work with large central sites. Yeah, we're not gonna get into all this, guys. This chapter it's a great chapter, but not getting straight to the point. All right. One size fits all or not. So again, these are choices that you need to make. Define the size of a subnet. All right. Before you finish this book, you will learn all the details on how to determine the size of a subnet. For now, you just need to know the specific fact about the size of these subnets. Chapter 12, analyzing classical IPv4 networks, and in Chapter 13, analyzing subnet masks, will give you progressively deeper knowledge of the details. The engineer assigns each subnet a subnet mask, and that subnet mask and that mask, among other things, defines the size of the subnet. So you need the subnet mask to truly identify what's going on. Okay, the mask sits aside a number of host bits whose purpose is to number different host IP addresses in that same subnet. Because you can number 2 to the x things times 2x times x bits, if the mask defines h host bits, the subnet contains 2h unique numeric values. Okay. However, the subnet size is not 2 to the h. All right, it's 2 to the h minus 2. Because remember, 2 to the h minus 2, we have to. Reason why we're removing 2 is to remove the broadcast address and also the network ID address. All right, so the broadcast address and the network ID address. Okay. Each subnet refers the numeric lowest. Each subnet reverses the numeric lowest value of the subnet and the numeric highest value as the subnet domain, as the subnet broadcast address. As a result, the number of usable IP addresses is 2 to the h minus 2. Holy moly, guys! Man, I am really stumbling tonight. I am so sorry, everybody. I apologize. You guys are probably getting wicked confused right now. Yeah, I'm struggling to read right now. I really should have got more sleep. All right. No, we're gonna push through this. Don't mind me. We're gonna push through it. All right. Note the term subnet, subnet number, and subnet ID and subnet address all refer to the number that represents or identifies a subnet. So that this is again just a graphic, just a good graphic. All right, one size fits all. All right. To use a single subnet in an enterprise network, you must use the same mask for all subnets, because the mask defines the size of the subnet, which. One requirement to consider when choosing that one mask is to that one. I cannot read tonight. Plus, some of the way this is written is just like really messing me up. Provides enough host IP addresses to support the largest subnet. To do so, the number of host bits defined by the mask must be large enough to support 2h minus 2, is larger than or equal to the number of host IP addresses required by the last subnet. Whew, man. For the example, consider it shows the required number of hosts per LAN subnet. The figure ignores the subnets on the WAN link, which require only 2 IP addresses. The branch local area network subnet requires only 50 host addresses, but the site local area network subnet requires 200 host addresses to accommodate the largest the largest subnet. You need at least 8 host bits. All right, 7 host bits would not be enough because 2h minus 2 is 126. All right, so 2 to the 7th, 2 to the 7th minus 2. 8 host bits would be enough because 2 to the 8th minus 2 is 254. All right. Which is more than enough to support 200 addresses. Cool. Whoo, Nelly. Man, I really should make more fun. Let me go have one of my my oldest make me some more coffee real quick. Hold on, guys. Thank you. Nice. Nice. My son's being obsessed with he's obsessed with Warzone. Playing it on the Xbox. I tried to download Warzone the other day. I was unsuccessful at downloading it. I'm gonna take a seat, guys. And we'll continue on. Alright. Let's continue on. Alright. Let's get over here. Let's get over to this. Alright, we're back over here. Alright. So let's continue on. I'm just gonna take a seat, guys, real quick. Like I said, all of a sudden I'm not feeling too groovy, but we're gonna keep on keeping on. Alright. Multiple subnet size, variable length subnet masks. Okay. Create the possible subnets. Yep. The small subnets now waste fewer addresses. The subnets on the right need 50 IP addresses. 50 IP addresses and have 6 host bits. 2 to the 6th minus 2, all right, equals 62. Yep. All right. However, some are still wasted because you cannot set the size of the subnet as an arbitrary size. All subnets will be replaced to the h minus 2 formula, with h being the host bits defined by each subnet. Okay. All right. One mask for all subnets, or more than one thing. Let me try to make some sense for you guys real quick. All right. So again, this again is representing the network portion, right? And that's represented by, because we have the slash notation 24. All right. I'm gonna have to write this all down. Oof. Let's bring up a calculator. Yeah, I'll just fix this. Look. Mod on. There, now we're working. -2. All right. All right. Let's get cracking. Woo, boy. Like I said, I'm having a rough time tonight. My brain is like it's broken all of a sudden. All right. Let's do some math. All right. We need to do some math. All right. All right. So again, here's our formula. 2 to the h minus 2. Okay. So what this is breaking out here, all right, is the need for what was the need? They needed 50 addresses. All right. So they needed 50 addresses. All right. So with the need of 50 addresses, CE, so 7 to the power of 2 equals 49 minus 2. So that only gets us 47. So that doesn't get us to 50 yet. So that's why we had to settle, all right, on 8 to the power of 2 equals 64 minus 2, all right, gets us 62. So that's how we get 62 addresses, okay? So 8 to the power of 2, all right, minus 2, all right? So that's we're using, it's just simple math, all right? Something real quick. All right, let's move on. Public IP address, public IP networks. The original design of the network of the internet required that companies that connected the internet had to use to register public. Yep, and that's what made the Class A, B, and C networks. Well, after submitting paperwork, the company would receive an assignment for either a Class A, B, or C network. All right. Public IP networks, the administrator, insured, yep. So the growth exhausted of IP addresses. By the early 90s, the world was running out of IP, public IP networks that could be assigned. During most of the 90s, the number of hosts newly connected to the internet was growing at a double-digit pace per month. Companies kept on following the rules, asking for public IP networks, and it was clear at that the current address assignments scheme would no longer continue without some change. Simply put, the Class A, B, C network supported by the 32-bit IPv4 standard was not enough to support one public classful network per organization. Okay. Some key topics: a new version. So IPv6. We'll be getting into that later. It uses 128. All right. So IPv4. All right. Uses 32-bit. All right. IPv6, on the other hand, is 128 bits. All right, not B bits, B bits. All right, big difference between the two. All right. Assigning a subnet, a subset of the public IP networks to each company instead of the entire IP networks to reduce waste, using a feature called classless interdomain routing. or CIDR. All right, classless intermain or routing. All right, SQL CIDR. All right, and then network address translation, which allows the use of private IPv4 address. Okay. Now you guys have seen that DHCP lab that I enabled NAT on the router interface, and if you caught my Saturday stream when I built the lab in EXXI that utilizes pfSense as a virtual router image. I had pfSense performing NAT on the interface that was connected to that NX bridge that I put a couple other VMs on. And yeah, it worked fine. It worked like a charm. It dynamically addressed all the addresses properly, and DNS and all that was working too as well. So I was really happy with how that whole lab came about. This is just touching on some of that NAT. All right. 3 solutions made a real network. The 3 solutions made a real network today. However, to say focus on the subject of design, these chapters focus on the third option in a particular third option in particular, the IP network that can be used by an enterprise when also using NAT. Beware that chapter 10 gives more detail about the last 2 bullet points of the book. Discusses. All right. Focus on the third item in the bullet list. NAT. NAT allows multiple companies to use the exact same private IP network by using the same IP address as other companies will still continue to connect to the internet. Oh boy. All right. Yep. So here's just a quick breakdown. Class A is 10.0.0.nothing. All right. Number of networks 1. Here's another one. So this is Class B now. All right, 162.16 through 172.16 through 172.31. All right, and then you have 168.168.2 for 5. All right. All right. Avoid using other organization public address ranges for private. Yep. Okay. All right. Choosing an IP network during the design phase. Today, some organizations use private IP networks along with NAT. I'm just gonna have to pop open the CML, guys. We're gonna have to do this in CML. All right, so Class A, you have 16,707,214 addresses. Class B, you have 65,534, and a Class C. All right, that's the oh boy. So you get Class A, B, and C. So Class A, that's the 10 dot whatever network. Class B, that's the 172.16. All right, and Class C, is the 192.168.0 to 192.168 dot whatever. Okay. Borrowing host bits to create subnet bits. We're going to be doing that shortly. And that, yeah. All right. just going over some of the ranges. Let's do this thing. It's good to be bad. Oh. Yeah. Yeah. That's Alright. Zoom in a little bit so you guys can see this a little better. Let's lab some stuff up, guys. I need a lab so I can wake up. Get those two fired up first. Real quick, I'm gonna go check on my coffee status. Hold on, guys. My coffee status. One, go. No. No. All right. Coffee's coming. Firing up. Let's make some. What we'll use as well. Let's add. That's fine. That's fine. Two. Three. Up. Let's put these up now. It's just always easier for me to do this stuff in lab, guys. Always easier for me to do this stuff in lab. Come on. Christmas probably too. Enjoy some Christmas. This stuff should not be This music should not get me in trouble. I hope everybody's gonna have good Christmas today. How do these overlays look, guys? You guys like these? Not working. I mean, they are working, but the little subscribe follower thing is not. I don't think it's working because it should be showing at least my latest followers at least. We'll fix that later though. We shall fix it later. Moved up. Good. Alright. Let's start doing it. Come on, that's it. Almost there. No, no, and no. To the roof. Bum, bum, ba, ba, ba. We're here. I know. Alright, let's think about what we're going to be doing for some addressing, guys. Again, that's the most important part of what we're going to be doing in this topology here. Let's choose a different color. So let us choose, keep things simple. Let's choose the 10.1.1.0 network, and we're gonna say this is the /24. And then this one right here, this is the 10.0. This is the 10.2.0, 2.2.0 network. Alright. And then this one right here, this would be the 10.0, 10.2.1 10.0.1.2 network. And this one's the 10. I keep on saying dot. 10.1.2. So those are, so we, what I'm just doing is I'm just trying to get an idea of how I want to do everything. And you're saying I'm going to be wasting some addresses here. Well, yes, in a way, I guess you can say that. Because what I'm going to do is I'm gonna use, this is gonna be my networks, okay, and then that's my host bit. Same thing all the way around. All right, so we're gonna have four different actual networks. So the 10.1.1, the 10.1.2, the 10.2.2, and the 10.2.1. All right, they're all gonna be their own. They're all going to be on their own little. They're all going to be their own little LAN. Okay. All right. And what we're going to do is we're going to configure addresses respectively on these routers, and they should be able to communicate throughout this whole entire network topology. We could give them all the same addresses, but that won't work. All right. It's not the right way. It's not what we should be doing. So. So on the interface, gigabit 0.0 go for IP address 10.1.1.1. So 25.25.25.0. Got. All right. That's cool. And moving to the interface 0.0, gigabit 0.0, IP address 10.0, I'm saying 0, 10.1.1.2, we'll say 25.25, 25.25.0. Oh shit. Alright, once that comes up right now. Now we already have, we should be able to ping that other network device already, so. And there you go, we already have communication with that other router. Now let's do our other interface now, and that's interface gigabit 0-1. Gonna say on that one, IP address. Alright, I'm going to say IP address 10 dot, I'm saying 10.1.2.1/25.25.25.0. No shot. Let's come over to this one now. Alright. we're going to say on interface gigabit 0-1 IP address 10.1.2.2 255.5.0 no shut. Alright, now we should be able to do ping 10.1.2.1 and we should be able to ping that other router now. Good. And now we're going to move into the interface gigabit 0-0. The address this is going to be 10.2.2.1 255.255.255.0 and got what are you doing? I am a hot potato mess right now, I'll be honest. Gigabit 0.0 IP address 10.2.2.1 255.255.255.0 got the no shut. Oh, what did I just do? Come in. Come in. Come in. That was fast. Thank you, babe.
Okay.
I got a coffee delivery. Thank you.
Welcome.
What I needed, guys. It's what I needed. Get me through. Get me through. Like I said, I'm hurting. I'm a hurting bird. I should have got more sleep. Joe's like brain is like, it's like, blah, blah, and I'm trying to do subnetting tonight. Like I'm halfway asleep right now, and that's not how I want it to be, you know, treating you guys. The last thing I want is, I guess, to be wasting you guys' time by disrespecting you guys by not giving you guys the 110% of my utmost attention to you guys. You guys deserve it, man. You guys are spending your hard-earned time with me. Every time she makes me cry, it's always a little green. It's okay. We love her though. We love her. All right. Coffee. Alright, I had to give it the no shut because I totally biffed. AFF. 2.2. Where are we? 2. Now we should be able to bang, do bang. 10.2.2.1. And now we gotta go into interface, gigabit 1, address 10.0, 10.2.1, 0. That. Interface gigabit 1 address 10.2.1.225.0. Let's exit. Let's just write those. Exit. Write those. Exit. Exit. Oof. All right. So we got our address schemes out. All right. Let's go back to this router. Let's do a do show the routes. So right now, our router is currently not showing. Well, it's just showing. It's only showing. Let me get over to the zoom view so you guys can see. All right. So right now our routers, it's only showing what is connected. So that's router 1 right now. I should have changed the names. I'll go. Let's do that right now. That way you guys can see them. So what we're actively doing when you guys are in this view. Oops, go back. One. All right. So what I'm saying is out of we only have in our routes, our routing tables, okay? This is our routing tables, guys. All right. It's only showing what is connected to us, okay? So we're back on R1, and remember on R1, we have the 10.1.1.0 network, so the 10.1.1.0 network, and we also have the 10.2.1 network. Okay, those are actual 2 different networks. Okay, all right, but those are what's connected to this router. Now, even though I have all these routers hooked up, I don't believe I should be able to do ping 10.2.2.1. I'm not going to be able to ping those networks because they're not in my broadcast domain. All right, they're in a totally different broadcast domain. Yes, they are all connected, and I'm going to enable that. All right, but what this is representing though is we only have particular. And let's go back to the other view real quick. So we're only getting information this way and information this way from this router right here, okay? All right. From router 1. We can only interact with these 2 routers, okay? We cannot interact with router 4. We cannot interact with router 3's that interface. We cannot interact with router 2's that interface. Those interfaces are in totally different subnet domains. Okay, they're in different cities. How's that? So we have a way. So this is our our wide area network, okay? What we can, well, I mean, the way I've got this set up, everything's a wide area network. There is no local area network. The only local area would be just these interfaces. They're only local to themselves. That's why you see local, because that's they're only local to themselves in this type of setup. This type of way I did it. Alright. Now, though, what we can do is we can implement a routing protocol on these. Alright? We can implement the routing protocol that will dynamically, OSPF is a routing protocol. And what OSPF does is it starts talking to, it starts making neighborships, and it starts allowing these routers to advertise their route tables out to other routers, so other routers can take that information and learn where to forward that information to. Okay. Let's do interface loopback. All right, loopback 1, loopback 0. All right, let's give it that. Let's give router 1 the loopback address. All right, of 1.1.1.1. All right, 255.255.255.255. All right, got. All right, exit. I'm gonna say router OSPF. I'm gonna say router OSPF 1. All right, we're gonna say network 0.0.0.0 and 0.0.0.0. All right, area 0. All right, exit. I'm over to router 2 now. Move into interface loopback 0. Give that an IP address 2.2.2.2 25.25.25.25. Dot. Exit. Router. OSPF 1. Network. 0.0.0. 0.0.0. Area 0. And look at that. We already made, right away we made an adjacency. So look at that. So it's almost not always that fast. It was that fast. Now let's go back over to, and it already made an adjacency over there. Now let's do a do. Now we're back on router 1 again, okay? Let's do a do show IP routes. Alright, and look how we're already starting to fill up. We're starting to create a routing table now. A bigger routing table, okay? We're connecting to other networks. So you see the O here, that's OSPF, it's learned at OSPF. So via OSPF, it's learned that the 2. All the way to 32 network, the 2.2.2, that's connected via 10.1.1.2, right, at the gigabit 0-0. So out of this interface, it knows it can get to the loopback address of router 2's, all right? And then same thing, out of that same interface, all right, it knows it can get to the 10.1.2 network. So out of router 1's interface, it knows now if it sends packets out of this interface, it can get to this network. Okay, all right. Now we can ping. We should be able to ping routers for this interface. So let's do ping 10 dot, so what is that? 10.1.2.2. Okay. Watch this thing. Okay, so look back. 0. Say this is the all 4, so we're gonna say IP address 4.4.4.4 25.25.25.25 shut exit router OSPF on network 0.0.0.0.0.0. Alright, area 0. Good. And look at that, we're already making adjacencies. Good. Let's just fix this. Interface. Loop back. 0. That's the all 3s. 3, 2.5.5.0. That. Exit. Router. OSPF. 1. Work. 0. 0. Yeah. So everything's, I believe, is so far made adjacencies everywhere. Probably got, yeah, we even got some adjacency messages over here now. We probably have some adjacencies over there. Yeah. Let's do a do show IP route. Now we have a nice full table of props. Let's do that same thing. Do ping and dot 0 1.2.2. All right, and let's do another ping, and that's 2.2.2.1. That works. And 2, and that works. That's everything. Alright. So what we did now is we added a routing protocol to now allow us to communicate throughout this entire topology now. Alright. I guess where I'm going with all that, so I don't get too off the beaten path here, is what we did is we, and again, my topology is probably not the best for this to be understandable, but we pretty much said that this is its own broadcast domain. Right? This is its own broadcast domain. This is its own broadcast domain. This is its own broadcast domain. Okay, they're all separated. All right, though they're resigning. They look like they're connected to each other, but logically they're separated. Okay. Yeah. wiped out. What up, Prosper? How we doing, brother? Thank you, my friend. I appreciate you dropping by. I'm a heart and bird tonight, man. I was up all night after your stream, my friend. Because I'm trying to get ready to take over an overnight position, so I'm trying to get my body ready to be up all night. Boy, it beat me up today. That was probably the big mistake I did. I'm a hot mess today. Oh yeah, so he's played Sundew Valley. I played Sundew Valley a while ago. That game is such a fun little game. With all the fishing and stuff like that you can do in that game. That is such a fun little game. Fun little game. How'd it go? How'd the stream go though, brother? Hope it went well for you, man. You're an awesome dude, man. I appreciate all the love you showed me last night. That was unbelievable. Unbelievable. Trying to do my best to drink as much coffee as I could, and maybe I might even spill some in my lap to wake me up right now. Good, man. Good. I'm glad to hear that, brother. Coffee. I don't know how you like your coffee, but I take mine the way the good Lord himself made the coffee beans, straight black. Dude, you're awesome, man. I appreciate that. Much love, man. Oh, there I go. I'm spilling most of my coffee in my lap anyways right now. Hopefully that helps wake me up. Oh, I'm over here trying to demonstrate subnetting, and I think I'm biffing it. G Fuel. Oh, so you're gonna be playing some more of that tonight? Yeah, I'm definitely gonna be up tonight, man. I'll jump in your stream, brother. Because again, I gotta get my body. I gotta get my body ready. Starting tomorrow. I'm up on the overnights. Most definitely. That's a pretty cool game you were playing. That Katana game. Katana Zero. I like that game. It was a cute little indie game. Oh boy. Yeah, well, I was working on, what was it? Yeah, I continued to work on night, like I was talking to you last night. I continued to work on Nightbot all night, and then I worked on changing some of this up for today, for today's stream, to give everything a little Christmassy look on everything. Obviously, this was, this is all kind of put together. I got a kick out of making this though. This was fun right now, but seeing my little guy in the background, let me kick myself out of the way for a second. This little guy was fun to make, and this was an animation I made in After Effects, and I figured out how to. It's just I put him in a green screen, and then I pretty much just like green screened out the background to put him on top of the background overlay. I'm gonna be making more stuff like this as we continue on for the streams, man. But that was pretty dope. I got a kick out of making that. I should probably add him in here so he can fly around. Thanks, man. Yeah, let me see. A lot of my stuff. I mean, if you looked at my other stuff, a lot of the other stuff I had done my best because I had started off in well, a lot of the stuff I built right off of Photoshop. This obviously is all downloaded overlays tonight, just for the Christmassy stuff. But a lot of the other stuff that I had on OBS, that was all the stuff that I had done my best because I do a lot of stuff in Blender too. I'm trying to teach myself how to get good with Blender and Photoshop and stuff like that, and After Effects too, to try to add, that way, don't have to like depend on paying expensive artists and stuff like that to make stuff. So that stuff's fun to learn. After Effects is such a neat program, man. Such a neat program. So isn't Blender. I love Blender. I don't know if you've ever messed with Blender. Blender's free. Blender's open software. If you ever get around to it, I believe it's blender.org. Yeah, it's blender.org. It's one of them. I have it saved too. Where's my Blender stuff? Stuff. Yeah, but Blender's awesome, man. Yeah. All right. Let me get back to trying to. All right, where else can we go with this network here? Let me erase some of this stuff. That stuff. Pouncing on that. Where are we at for? Guess what I could do? What I could do is. A couple unmanaged switchies real quickies. Couple unmanaged switchies. And see if I'll boot something up. Some PCs in it. Say, man, I am brain farting like crazy tonight. Holy guacamole, guys. Holy guacamole. Alright, so this will be the I'm just gonna say the dash twos. Let me just say it. Command 1. I don't want to get crazy with my naming schemes. Command 1. Command 2. Three. Unmanned 4. Let's go ahead, jump into the CLI. Now what I will do, let's do this. I'm gonna make a DHCP server for everything. What I need, it's not gonna work though because interfaces. So let's do this. Gigabit 2. The address. This will be the all. I'm gonna say the 3s. All 3s. 1. Zero. How we doing? What we got here? Bang Bang Bullet. Hello there. How we doing, Bang Bang Bullet? Bang Bang Bullet, if my boy Prosper's still in there, how about you go check out my boy Prosper too? But we doing some subnetting today, Bang Bang. I am... Yeah. Let me see. We started off subnetting. Now I'm just fooling around, I guess now, with IP routes and whatnot. That's pretty much where we're at right now with everything. Just trying to get woken up by gobbling down some more coffee, and hopefully once I gobble down more coffee, I can screw my head on a little bit tighter. Oh, cool. Prosper, you still in, man? You're awesome, dude. Yeah, Bang Bang. Like I said, man, check out my boy Prosper. My boy Prosper, mate, he does some amazing gameplays with indie gameplays over on his channel. If you're into indie gaming, check him out. Interface. To the address. 4 through 5. Let me do show. When do we hack the NSA? Never! When do we hack the NSA? That's awesome. That's funny, Bang Bang. Gonna fight myself out of a paper bag right now. I knew that wasn't going to work, but I just did. It's not going to work, Joe. Fundamentally, everything you just did was wrong. Wrong. Ah, that fixes that. Yeah, I biffed it earlier, so what I was doing wrong was definitely wrong. So now I just pretty much just fixed what I did earlier, and now everything. Yep. Okay. So now though, if I go back here, that's it, and let's do DHCP pool. I'm gonna say one. Say network. 10.0.0, 10.1.0, 5.0, default will be 10.0.1.1, exit, IP, DHCP again, and 2, this will be network, 10.0.2.0, 25.25.25.0, default, that would be 10.0.2.1. Again, 3, network, 3.0.2.0, and default gateway 10.0.1, and that's it. One more time. P pool. Work. 4.0. Now that that's up, it's up. Let's do a do show run now. So we got our DHCP set up all nice. Go. Just get some of these PCs up. Just to make sure we're getting our address. I might have to add a command to each one of these router interfaces. We'll see. Yeah, so I might have to add a command to some of these interfaces on these routers. We'll see in a second. He's good. I'll know if I don't get an address on this that I'll do that again. And I didn't. Yeah, okay. That's cool. So then I have to do the interface. Gigabit 0-1 IP helper. IP helper, and that's 10.0. Yeah, I can aim it towards that. 10.0.10.1. Gigabit 0-2 helper 1.1. I did it. Cool. Got our address. So I need to add the. Let me just add it to this interface and see what happens. So interface. Are we in that interface? Oh, we're already there. Okay, so let's just do IP helper then. 10.0.1.1. Curious if that's the only interface that I'll have to do that to. He should be able to ping. Yep. All right. So it's only this actual interface that's facing it. So I can actually remove. Well, if I go back to interface gigabit 0-. one? Yeah. And I can give the no IP helper. That'll be good. Let's do right on this. Let's come over here. He didn't get an IP address, but I'm just going to confirm he has no IP address. Put the login name. So let's just add, we're going to add that command to this interface right here. That is interface gigabit 0-2. That's IP helper 0.1.1. That's it. Cool. Cool. And yeah, now all these PCs now, they should be able to ping everybody la-di-da-di in 4-2. Yeah. And over here, let's exit. Do right on all of our routers real quick. Let's exit. Let's go do right. Make sure we save our configurations real quick. Let's do a do right. Save it one more time. Sure, all of that looks good. Now let's do a do show routes. Got a beautiful table now. Very good. Very good. So what we've, dynamically done is we've created a whole bunch of different subnets. Yeah, we've created an array of subnets over here. So you don't pay any mind to these. These are all loopback addresses, okay? All right. But over here, this is a broadcast domain. This is its own broadcast domain. This is all these are their own broadcast domain, okay? This is connected locally, obviously connected locally. But this is connected locally as well. Alright, so we got a nice little lab up and running. A little bit of a different style lab. Even though this was a little messy, my opinion, I would have done this a little bit differently. Put a little bit more forethought behind what I was actually doing. I would have done this a heck of a lot differently. Yeah, we're gonna have to get back. We're gonna have to probably review chapter 11. I kind of feel as though, yeah, I kind of feel as though I lost where I was going with that chapter review tonight. So I kind of have to apologize for that. I guess it's not too late to get back on that horse again. kind of review it more. You know, in a sense, this is what I was just trying to, I guess in a sense, this is what I was trying to demonstrate was so this obviously is representing this is representing a wide area network here, okay? Wide area network, okay? All right, these are representing the local area networks, okay? Land. Back. All right, same thing here. These are representing their own local area network. Local area network. All right, and as you can tell, so when you have the slash notation 24. What it's stating is everything from this area back, same thing, this area back. This is all the networks. This is the network part. All right. These zeros, these are the host parts. All right. Same thing on the wide area network, same thing. All right. Network and then host. All right. Network host. I guess what I need though to talk to you guys about is so these are the private network ranges. So the all 10, so the 10.0.0.0.0, that's the class A. That's the first class A network, okay? That's what begins the class A, the private. All right, these are private addresses. These ain't publicly routable addresses, okay? These are what you can do inside of your own local network, okay? So as a network designer, you're gonna take, you know, you're gonna either, so that's why in your house. So in your house right now, if you look up the IP address on your phone, on your laptop or whatever, you're gonna have the 192.168 network. I can almost 100% guarantee it. You're probably going to have the 192.168. That's more popular for most home routers to have. You know, potentially you could have the 172.16 potentially, but most home routers are using the 192.168 as the private address within the local area network inside of your house. So inside of your house, that's your own local area network, and I guarantee your router is using most likely a Class C, okay? And that in that you have 256 networks, all right? 256 networks, all right? Because we can use the range of 192.168.0.1 all the way to, we'll go to the next one, 192.168.1.1, all right? 192.168.2.1, all right? 192.168.3.1, all right? So these, and we can keep going all the way to 192.168.2.5.1, all right? So the very first address is the 192.168.0.1, and then your very, very last address is the 192.168.2.5.254. That would be the last so this would be your very first address. This would be your very last address, okay? But you're gonna have 256 networks to play with, okay? So you're gonna have, this is your first, so that 0 right here, that's the first network. The 255 is the very last network, okay? So So that's how you get the 256 number. The 256, all right, the 256 networks comes from, you're going to start at 0. You know, you can use all the way up to 255, okay? All right? But this range, though, it goes from 1 to 254 in each one of these networks, okay? Remember, you're going to save 1, you got to save 2. 1 for the broadcast and 1 for the subnet ID. So you have to minus 2, and that's where the 2H minus 2 comes in. Is you're saving, you have to take away 2 for the subnet ID and then the broadcast domain. All right. And then you have the 172.16.0.0 network that goes through 172.31.0. All right. So from here, similar type. Similar type thinking. So you got 172.16.0.1. All right, and then you have 172. All right, .16.1.1. Same thing. 172.16.2.1. All right, 172.16.3.1, and then you can go all the way up to 172.16.31. No one, yeah. So 172. 172.331.25.1. There you go. All right. So there's a heck of a lot more address ranges in the 172 because so you're going to be in the range. You're going to continue to build. So in here there'll be the 172. 17.1.1. That's going to be in there somewhere. You know what I'm saying? The 172.18.1.1. That's going to be in there. The 172. We can keep going, guys. I mean, the numbers are exorbitant. All right. Same thing with the 10s. All right. The 10s. That's a class A. There's 16. How many addresses are in the class A? Class A. Oh, I had the number. Where did it go? I had that number written down for the longest time. Oh, it says it up here, though. There's a good graphic on. But either way, in the 10s network, there's like 16 million. We can come up with 16 million host IDs. All right, 16 million. It's a big number. All right, and that's why. Oh, so there it is, Class A. So you can come up with 16,700,077,214. All right, host. With Class B, you got 65,534, and then with a Class C, you got 254. Okay, so yeah, you can make a wide range of networks here. All right, so that's pretty much it. Yeah, I apologize, guys, for being so wiped out jumping on, but we'll be picking up back tomorrow. Maybe we'll do another review on Chapter 11 before we get into Chapter 12. Chapter 12, though. Go over here. Chapter 12. Chapter 12, we're going to be diving into my DevNet book. I'm not doing the DevNet tonight. Studying too many things at the same time, I think. Analyzing classful IPv4 networks. That's when we're actually going to start breaking these networks down, guys, and then figuring out the math behind it. Chapter 12 is that'd be our headache. That will definitely make our brains hurt a little bit. Yeah. Chapter 12 is like the chapter that we're gonna be having to do some math and whatnot. And that should be good for us. All right. So, again, guys, thank you all so much for joining me tonight. It's been a great night. I hope to catch you guys tomorrow. Again, same time, same place, 5 o'clock Eastern Standard Time. Y'all have a good night. All right, I'm gonna go try to get some grub in me and maybe take a nappy nap. But I'll probably be up all night though. All right, I'll see you guys later. Have a good one, y'all.